Hi, I'm Aissani Linda. I'm a senior lecturer from Ouargla University of Ouargla. I would like to share with you this interesting study in form of poster entitled Microstructural and Mechanical Characterization of Hard Magnetron-Sputtered Zirconium Nitride Thin Films on XC100 steel substrates. The hard coatings offer a respectable solution to the wear and abrasion problems. The most frequently material used are the transition metal nitrides such as chromium nitride, molybdenum nitride, titanium nitride, and zirconium nitride that result by diffusion of nitrogen. The hard zirconium coatings produced by physical vapor deposition, chemical vapor deposition, or by means of electrodeposition techniques with few microns thickness enhance the mechanical resistance of various parts. Zirconium nitride thin films are effective in protecting steel and various alloys from chemical attacks. Nowadays, it's considered the best choice in various industrial applications. The main aim of this work is to evaluate the possibility of using nitrogen gas as a source of nitrogen in order to create very coherent hard zirconium nitride coatings by means of diffusion and transformation process. The influence of nitrogen flow rate on the structural, morphological, and mechanical properties of zirconium nitride were studied. Zirconium nitride thin films were synthesized using radiofrequency reactive magnetron sputtering on XC100 steel substrate at different nitrogen flow rates. The crystalline structure, morphology, and mechanical properties of the produced films as a function of nitrogen content were characterized by X-ray diffraction, SEM and ADS, IFM, and nano-indentation. Now let's see results. From XPS spectra, we can see clearly that the increase in nitrogen flow rate delivered an increase in nitrogen content and a decrease in zirconium content in films, where film thickness was found to decrease gradually with increasing nitrogen flow rate. And a ratio of about 1 was obtained at 20% of nitrogen flow rate. The X-ray diffraction spectrum of zirconium nitride films showed that the film were composed of a mixture of ZR2N and well-crystallized ZRN phase, with low intensities of ZRN and ZR2N. Lattice parameter was found to increase with increasing nitrogen flow rate, where the grain size was found to increase firstly and then decrease with increasing nitrogen flow rate. The morphological analysis of zirconium nitride thin film showed that with increasing nitrogen flow rate from 10 to 20%, zirconium nitride coatings relieved a compact columnar structure with small grain size. The nano-indentation test of zirconium nitride thin films showed that the hardness and elastic modulus relieved a modification as a function of nitrogen flow rate, where the best value of about 22 gigapascal was obtained at 20% of nitrogen flow rate. That was all. Thank you for your attention.